Okay, so in 3.3 we're looking at surface area. Surface area of a 3D object is basically the surface area if the object was broken down flat into, this is a storage bin which has been broken down flat into 6 different sides, including the bottom. This is called a net. So if you're looking at 3D objects and you want the surface area, breaking it down into a net is probably the best way to go as to finding the total surface area of all the surfaces. This particular one, example 1 here, is a bin that's 4.4 yards in length, 2.3 deep and 2.8 yards high. If we broke all the sides down, the dimensions would be given here, as you can see in this diagram, for the 6 surfaces. So now we can calculate the surface area of each particular rectangular square. So there's area 1, 2, 3, 4, 5 and 6. We know the length of this here is 4.4. It's over here. So all of these have the same length, different widths. So surface area is just length times width, and we can add all 6 surfaces up. So the calculation is shown on this page. And of course in the end you'd be adding up all 6, which would be here. Fairly straightforward. There is an alternative solution that you can read through right here on page 144. So perhaps what I'd like you to do in class is to do the following, build your skills 1 through 3 based on that example. Example 2. Talking about a canning factory wants to use as little metal as possible to make its cans. It considers two can sizes, excuse me, that each hold about the same amount. One is 4.5 inches tall, it's this one here, with a radius of 4.2 inches. And the other is 9.6 inches tall, radius of 2.5 inches. Question they're asking here is, which can should they use and why? It wants to use as little metal as possible. That's the trick. As little metal as possible. So let's just highlight that. Well, really this is a surface area question. We want to add up all the surfaces in each can and find out which can has the least surface area. So let's scroll down here. And first of all, I guess we need to look at our data pages. Data pages will give us the equations we need for surface area. The top and the bottom of a cylinder is a circle, so the area of a circle is pi r squared. So that's this right here. And we have 2 of them, top and bottom. What about the side of the can? Well, the side of the can, if you were to unroll this side into a flat sheet, it would be rectangular. Excuse my drawing, but this would be 4.5 inches, and this would be equivalent to the circumference of this circle. Circumference is 2 pi r. And of course this is what we call the height of the can. So the area of this rectangle area would equal 2 pi r times the height. And to that we add, for the whole cylinder, we add pi r squared times 2, because the top and the bottom. Okay, so let's have a look below, scrolling down. they look at the dimensions for both cans. So can 1, we have the area of the top and bottom, which is 2 pi r, and the radius was 4.2. So the area of the flat surfaces top and bottom is 110.8. And the side, as I said before, is 2 pi r times the height. So again, r is 4.2. The height of this can was 4.5, giving an area of 118.7. We're adding both these two areas together to give a total of 229.5. Can 2, the same idea. Area of the top plus the bottom, and this gives us 49.2. Area of the wrap around the side, 2 pi r times the height, and those dimensions for the radius was 2.8, the height was 9.6, giving us 168.8. If we add those together right here, we get a total of 218. So it looks like in the taller can we actually use a little bit less metal. That's what they're asking us to do there. Okay. So if we scroll down, there's questions 4, 5, and 6 based on example 2. They're talking about not only a can, cylindrical shape is a can. In question 5 they're looking at a cylindrical box, so it is a cylinder again. And in question 6 they're looking at a conical funnel made out of sheet metal. The funnel is 9 inches tall, this is slant height. So in this case we're not looking at a cylinder, we're actually looking at a cone. So use the formulas for the cone, funnel. And what does it say just there? What is the surface area of the sheet metal? Okay, so remember, conical funnel, the funnel is open at the top. Example 3. Harry has to paint the walls and ceiling of his room. A room that is 12 foot long, 10 feet wide. That's the dimensions. So when we think about that, 12 foot long, 10 feet wide, so it's 12 by 10 feet. Now it's also, so that would be equivalent to the floor plan of the room, but remember that's also equivalent to the ceiling. So this gives us the area of the ceiling in a sense. So area of C for ceiling is going to be 12 times 10, or 120 square feet. So feet squared. Okay, what about the walls? Well, it tells us here that the walls are 8.5 feet high. There seems to be a window and a doorway as well, and a mirrored closet. What's the surface area he might paint? So remember, he's painting the walls and the ceiling only. So let's pretend that there's no window, no doorway, just all walls, and then we could subtract the window and the doorway. So we have walls that are 8.5 feet or 8.5 feet high, and one wall will be 12 in length. So that's this guy right here, okay, and also this one right here. So those two. So that'll be 12 feet. And one of the other walls, or two of the other walls, slightly different dimensions. They're only 10 feet. So this is 10, this is 8.5, and this guy here is the same as this one in the original floor plan. Okay, these are the same. Okay, so we have to find out what these are, and there's two of them. So we have 8.5 times 12 for one wall, and there's two of that size, and this equals, so we need our handy dandy calculator. So let me just do that. What am I getting? Well, it ends up being 2 times 12, which is 24, times 8.5, and we get an answer of 204. Okay, so 204 square feet. And this one is 2 times 10 times 8.5, so that's 85 times 2. So what's that? That would be equal to so 170. I believe, yes. 170 feet squared. So now we'll add up all three. The ceiling, 120. 204 for the two large walls. 170 for the two small walls. What is that? Total 9 and 4. So 494 square feet. However, some of that's taken up by the window, the doorway, and a mirrored closet. So we're going to subtract that. Okay. So we'll have to multiply 6 times 4, and separately 2.5 by 7, and separately 6 times 7, and subtract that from the 494 that we have. Just going to clear this and we'll scroll down. So there's the 494. They've calculated the area of the window, the area of the door, and the area of the closet. So the area of the window is 24, door 17.5 or 17.5, closet 42. They're adding the three of them together to 83.5, and now they subtract the 494 from all the other things, and they get their answer, 410.5 feet squared. That will be the area having to be painted. So, let's just see. So in class, questions 7, 8, and 9, but there are different shapes, and we'll leave it at that for the next class.